Okay, it looks like we're live, so welcome back. Today I'm going to be continuing to work on my scripting language. I have to open it up here actually, so let's do that right here. It's the GitHub repo. Alright, yeah, so I'm building a scripting language for my text editor. That is the plan. So let's see what we've got so far. So we have this. This is the scripting language, right? So we have two things that we can call, right? Native functions. So we can call write. So that's like the write syscall, right? And it will basically push this string, a pointer to the beginning of it onto the stack, and then it will write it to send it out. And then we also have exit, where you can find just a single number currently, and it will exit that exit code. So if I compile this, do that, it compiles to this this assembly right here, which is a custom assembly for my virtual machine bytecode. Yeah, so we have right. Let me look at it in Vim because it's a bit nicer at the moment. Yeah, so it basically compiles to this, which is the assembly for the virtual machine. And then what we can do is we can compile it, we can assemble it using the assembler. So that will create this the bytecode, right? So there's the string in there, the hello world string, and the rest of it is like instructions and things like that. So then finally we can actually run it. So using the runtime, we can run the binary file and it will execute and it will write hello world. And if we look at the exit code, it was 34. So that's what we can do right now. What I would like to be able to do is have expressions, right? So 34 plus 35, something like that, right? And I'd like to also take into account like order of operation, that kind of thing. So, you know, if you do times 2, it will do this 35 times 2 first. But first I'm going to get it so we can parse expressions like this, and then I will figure that out based on this operator precedence thing. It's not something we've done before, though. So it's going to... it might take a stream or two to get it right, and things like that. But I'm going to try to figure it out. So, first of all, we need to expand the tokenites, right? So we have these. We should probably have a token type operator, right? Or, no, we should have a token, not operator, we should have plus, right? Plus and minus. And then, should it be called star or multiply? I'll call it star. I'll call it multiply for now. And then I might change it in the future if we use it for something else, like pointers or something like that. Okay, so I need to add it to here so we can actually print it out. So it goes after the exit. So plus, it looks like that. Minus looks like that. Multiply, and I'm not going to do like modulus or whatever. Not yet. That's what we've got. So that is what we're going to do here, and we can go ahead and come down here. Let's see, where is that? Get token type. So how do we do that? Yeah, so it's just going to be in here. Just going to check the starting type. So I'm going to advance this pretty soon. So we'll just like read from an array. But for now, I'm just going to do like this. So if view.data equals a plus, then we're going to create the token with that. Let's see. So we can probably have a create operator token, right? Create operator token. And we'll set the token equals that. And then we will daily append the token. 2 tokens will append the token. So I need to make this function. So we're going to have to pass, I guess we can pass the right? That'll probably be useful. And then we can also have, we don't need much else because we don't need to append to any sort of string. So then we can just pass the type as well. So it'll be token type plus, right? What if we even just pass view.data, like the single string, or the single character, and then that'll be even simpler, because this would work for any of the operators, you know? So let's do that. So let's create this. So create operator token. It's just going to be a helper function, right? I'll put it right here. Alright, so, oops. Okay. So create operator token, so it's going to return the token, right? And this one is going to be a size type. This one as well, and this will be a character. This is called C. Alright, so we need to create the token in the same way that we're doing it here, pretty much. And let's see, we need that one without. Okay, so we've got that, and then we can switch over the character, right? Then based on that, so case plus, we're gonna set token dot type equals pt plus, and then yeah, we basically just repeat this. Let's actually add the break before we copy it. All right, so plus minus multiply and divide. That's this one. Okay. So this is minus. Whoops. Okay. Multiply and divide. Okay, so we got all of those. And then we can just return the token, right? I think that's all that we have to do for that, if I'm not mistaken. So we have the character. Yeah, but we need the default as well. So if it in the default case, we'll probably just print an error, and that's gonna cause a crash and everything. So we'll print the error. Expected. Like, we shouldn't get to this point because we're only going to actually call this function in that case. So maybe we should even just assert here, since it should not happen. So assert false, and so we should not ever get to this point actually. And this can be the assert macro that I have, because that is a bit nice. Okay. Yes, forgot that. So this could probably be abstracted away sort of into like an array or whatever to make it a bit cleaner, but for now I'll leave it as a switch statement so it's easy to read, at least at the moment. Yes, we should be able to call this anytime it is one of the operators. So I think what we could do is operator, right? We can have that function. And then we'll just pass the v.data in there. And once we get to the multi-character operators, right? So like that, we're gonna need to do this a bit of a different way. But for now we can do it like this. Like, we'll probably pass the whole thing into there. The whole string, and then we'll string compare on it. Yeah, but for now that is fine. So yeah. Is operators. Now you have to make that, it will return a boolean. Boolean is operator. And we're just going to take a single character. And yeah, I guess we'll just basically do the same thing. Alright, but we obviously don't want to assert false in this case. But for this, we'll just return true. And we can actually follow through for this, so we can take this, put it there, get rid of all of these, and there you go. So if any of those, we'll return true, and here we'll just return false. And that is that. So we have is operating, and then we can create the operator token if it is one of those. And that is pretty much it, I think, for that. So we should be able to parse them now, or lex them rather. The parsing can get a little bit more complicated. Yes, that should be that. So let's try to build that. View undeclared. Okay. Yes, that makes sense actually. So we need to pass. We don't have the column, so let's pass view.data minus stars plus 1, because that is what the column is going to be. View undeclared. Yeah. So we have to send it to column. That's my bad. In here. Like that. There we go. Okay, so those are not handled in the switch. That's okay. So we can get to that. So for now, it will just fall through, but we'll fix that up a little bit. So case, yes, just all those. pt plus case pt minus multiply. Let me do it in the right way. pt divide. Okay, so now it should combine. All right, so let's actually return 0 here, and let's print token array tokens and make sure it actually works. Let's build it and run it on payment.payment. And we do have integer plus integer, so that is correct. Yeah, so I guess that did work. First try. Obviously that's not exactly the complex part. Okay, it's actually pretty good. I just want to look at everything. Okay. Yeah, so now we're gonna have to get to the parsing, which is gonna get just a little bit more complex. For value, yes, the values we're still only gonna have integers. That's all fine. So what we need to do here is we need to make a new node type, right? So we need like type expression. So this is gonna be an expression, right? And then where is the the value? It's gonna be an expression, right? Expression. actually, I'll just call this expert because I think that's reasonable enough, right? So expert, and then the nodes have a location, a value, and a type, so that should still be all good. Yeah, so this is going to be an expression. Let's make that like an expression. So it's going to be some stuff here. So we need like an expression type as well. That's going to be an enum. Expression type. Okay, expression type, and then what else do we need? I guess we need the expression value. We need that. Yeah, I think so. So there's going to be a few different kinds of expressions. We'll have binary expressions, right? So that is like 12 plus 15. That's a binary expression. And then we'll have what are the other ones called? I don't remember what they're called exactly. I don't know if it says exactly. Yeah, but so we have that, and then there's the single one. So expression type. So we have binary expression, and then we have just, I guess, is that what you would call it? Like when it's just a single number. We'll go with that for now, and then we can make adjustments. So the expression value. So there's gonna be int, integer, right? Oops. Integer. There we go. And then we'll have binary expression. But bin. We just call that bin, I think. And so we'll make put it up here actually. The structure for the binary expression. Yes, we're gonna have to do some forward declaration stuff here to get it to work, because it's gonna be so this is like a tree, right? So we have the left-hand side and the right-hand side, and then we also have the operator. And the operator is going to contain a few different things. So I'll make that, and then I will get to the actual tree part. So the operator, it has the it's going to have the precedence, right? Precedence, which that'll probably become an enum, but for now I'll just leave this at with the precedence and then the actual operator type, right? Okay, yes, so there's a lot of stuff. It kind of goes pretty fast, but all right, operator type, which is going to contain basically all the types, right? So OP plus, OP minus, OP multiply, and OP divide, right? So those are the types of the operator. And the precedence, I'll just make it enum for that, enum. Yeah, so this is precedence. So we have basically prec 1, right? Yeah, prec 1, and then prec 2. And we'll have the prec count as well. So that, I'll put underscores here. Prec 1 and prec 2, okay. And then that is what we use for this. So, precedence. Alright, so basically, the precedence, 1 is for plus and minus, and then 2 is for multiply and divide. Okay, so we're getting there. So left-hand side, right-hand side, so that can be an expression, right? So it could be either another binary expression, or it could just be a single integer. So we'll need to do, I think we can do something like this. Type def struct, it is expression, right? And then we can change this to be like that. I think that'll work, if I'm not mistaken. It might not, though. I might have to change it up. Okay, so this is going to have an expert value, and then an expert type. Each expression is going to be that. So, like, a single number, single integer, like 12, is an expression, with a type of integer. I feel like it's okay, with the type of expert integer, and then the value of whatever the integer is. Yeah, and it all is going to break down into just integer values, right? Okay, so we got that out of the way. Let's see if it compiles. Bin expert, that does not exist. So I forgot the underscore. Okay. Expert is not a thing, so that is useless. Alright, yes, that didn't work. Precedence, I think I spelled that wrong. Precedence, there we go. Yeah, so it doesn't like that. Useless core storage class specifier, okay. So we need to be able to reference that. But we also need to be able to reference the binary expression in here. So how do I get that to work? I have to do like struct, right? No. incomplete type, and then also I need to do not a semicolon, right? Okay. But where's the other expert used? Where is that? 162. That's right here. So for the node values. Okay. So let's see. This is what I always have problems with. Okay. I don't think that's gonna work. Okay, so what if we do it the other way, right? This is type abstract expression. You're gonna have to mess around with it and see if I can do it. So we have that here, but then we put this under the binary expression, right? Take this and put it down here. Like that. And we forward declare that. So yeah, get rid of this one. And right here we put type abstract binary expression. So that might not work either. I don't know. And this we do it that other way, like how we were doing it. Binary expression. Okay, yeah, it's the same problem. Also, it doesn't like this, so yeah. So let's see. I would really like to be able to get this to work, because that would be pretty nice. Okay, what else? What else could I do for that? Struct binary expression. That is incomplete type. Okay, so let me look it up. Let's forward declaration of struct. Let's see if I can find something about it. Maybe the AI has a good thing. Struct my struct. That. That works with functions. But when you reference the struct itself, you know? In another struct. See if Google has something good. Probably not, because it's Google, but you know. Cannot be used in other structures other than declaring a pointer. Okay, so it needs to be a pointer. Oh shoot, this is supposed to be a pointer anyway, so we can do that. I completely forgot about pointers. Yeah, so that would work fine. If we grab this, put it up here. Actually, I should get up one more. There's gonna be 3 of these guys. Okay. Get rid of this one, and get rid of this one. Okay, I completely forgot about pointers. So yeah, this should work. Like that, strap that. No, just strap that. This part always confused. Okay, I think this will work then. Okay, so it does compile. So I'm assuming that'll work. So, all right, let's see what we've got here. So we have the expression, and it has a type and a value. So the type, let's see. I should put the types next to the value. So let me just grab this, because that will make it easier to read. Okay. Okay, so we have the type, and then we have the value. So the type could be either a binary expression or an integer, single integer. And yeah, that is reflected in the values. Okay. Sure. I find the wrong one here. This is supposed to be expert. Okay. No, that doesn't work if I do that. So. Wait, what do I have? Yeah, I'm gonna get rid of this. And yeah, that is why I did that. So this needs to be above that. Okay. Messing things up. But this should fix it. And this needs to go up here. Okay. With this drop. Alright, that should fix it if I actually get rid of this. Alright. I'm struggling a little bit. I apologize. Binary expression is not a thing. What? Oh, because we need to type that. bin expert. There we go. Okay, now we got it. Now we got it. That should be right. So yeah, then we have the binary expression, which has an operator, a left-hand side, and a right-hand side, which is in itself an expression. So it's, you know, self-referential. I can't pronounce the word. It references itself, right? That's what I'm trying to say. So then, yeah, here's the operators. So let's try to actually parse this. So what I'm going to do is anywhere that we're going to encounter an expression, right? So that's going to be, say, after the exit, right? This is not the parsing. Yeah, so parse native node. So let's go to that. So if we are expecting an int, which is right here, then we're going to parse expression, right? Parse expression. And we're going to pass the tokens, I suppose. Tokens. And then I think that's all that we need. So this is going to return, it's going to return a node. So we can't really have the args there. So how are we going to do that? Hang on, so let me look at this. Arg. Right, so this has arguments, which we need to actually push onto the stack. So we need to generate, so this is going to have to be handled a bit different. Aside from the arg. So this is going to generate a node unto itself, right? But I guess if we make the arg, here, let me look at the arg, definitely. Arg, so it has a type and a value, so let's make it an expression, like of the node, right? Var expert, and then we can get rid of the int there. And then the value, where's the value at? Var value. Yeah, so integer or expression. Okay, so this is gonna actually change a lot of things, but then that accounts for that. So I think we have, yeah. Where's the expression defined? So we need to move that down. So let's move the expression stuff up, right? So just all of this can go up. We'll go all the way down to here. We'll grab all this stuff and move it up. Like, obviously, header files would kind of fix some of these problems, but I'm not doing that right now. So it is what it is, right? Then we can actually reference that properly. So let's just, then we have to delete all this. Because we can let, the text does not support deleting selections like this and then copying. So it's a bit unfortunate, but it is what it is. Okay, we can get rid of the operator or the precedent stuff somehow. Okay, that should cover it. So now we should have moved it up there. And then, yeah, then we can reference it in here. So where is that? So var value, where's the var value? Oh shoot, the var value is all the way up here. Alright, so we'll have to move the reference to the this struct expert, right? We'll move it up here. Let's be a point, I suppose. Our int undeclared, so we need to get rid of that. Unknown name expert. Let's be struct. Alright, so 337, no value integer. So the, what is this? Okay, yeah, we need to set the expression. Let's see. Let's set the value as dot integer equals that, and token.value.expression type equals expert, right? Just a single integer. Since we use it there, and now I'm thinking maybe we should just change that and not use the var value for that. That's probably a better idea. So let's change that back. Let me undo what I just did. Token.value.integer can be that, and we'll set that so that the var value can just have an integer. Integer. We can get rid of this. Move it back down here. Okay. okay. And then we'll have to change where we use var value, right? And we'll use arg value, right? Instead. Arg value. So arg value, so it could have a string view, or it could have an an expression, right? So expert. So yeah, the value will be either one of those. And the expert could contain just a single integer. Okay, so now we have that, and then var int is not declared, so we need to... Yes, they should actually use arg value and arg type now. Because it's different, right? So we have enum. It's getting a bit messy, but once we move to a header file, it would be the arg value, arg type rather. So we have what's it called? So what do we use here? We use var. So this is arg, and then arg string, right? And I'll put it in the same order so it looks better. And then we have to change var int. We have to add a var int back. Okay. Yeah, we have to add it back to, where is it? Type. Var int, and then we'll search for what we use var int because it may not be valid, right? So that node value, yeah, so this is going to be arg. We have another offense. That was it. Okay, so we good. We is good. Build that. Conversion from enum. So it doesn't like that. 391. So where is that at? That is with the string. So it doesn't like the string. Archetype and enum anonymous. R's. Hey, let's look at that. So R. Where is the R? It must be down here. Archetype. So what is wrong with that? Arg value has no memory name. Integer. Alright, so we can get rid of that. Because this is going to be just going to be replaced with compiler expression, right? Yeah, so undefined reference, that's fine. Plus the decoration of that. So, oh shoot, it's not var string anymore. It is. Okay. It is now arg string. I think that's what the issue is, right? Not entirely. Oh yeah, so there's another one where we use var string. It should be arg string. Okay. There we go. So now we just need to implement parse expression, right? So what do we call that? Parse expression. Yes, we call it here. So let's make parse expression, which is going to return the expression, right? So parse expression. Parse expert, and it's going to take the yeah. So we're going to basically look at the next token. Yes, we'll look ahead, right? So we need actually to peek the token. So right now we have consume, right? Token consume, yes, and then we need we'll get token peek, which isn't going to be nice. It's going to be token peek, token array, tokens, and well, we actually need. So we just want to return the next token. Is that what we want? So we want to return token. Tokens, data, tokens, count. So not count. Not the first token, but the one after that. So like if the tokens look like 12 plus 3, well, 12 plus 3. So 12 is a token, and then plus is the next token. So that's the one that we return. That is what we want. Exactly. So we're gonna call. So this is gonna be the first operator, right? So token equals token array. Oops. Alright, so we do have to make sure. No, we don't need to do that. What's that about? Just that. Okay, we need to make sure that it is an operator. So how do we want to do that? I'm trying to think. So what's the best way to think about this? Maybe we should expect token. Well, no. What is the expect token? So that takes tokens and then token type. So that's not what I want. Right. Let's just go through it assuming it's all right. And then we'll go through and add the checks later. So operator. So we're going to get the operator. And then we have to we have to assign the value that is like operator. Ezra flag followed. Thank you. Appreciate that. So operator.value. Hey, so how do we get the token value? Let's look at the token definition. It's going to be at the top. Dot value, and we don't have, no, so that's the var value. So token type. Yeah, so we're going to look at the type. Right. Okay, so parse expression. So if it is, so we're going to take one of those, right? That's what we need to check with, but so we want to look at the type. And we're going to set that equal to the current operator, right? So we're going to create an operator based on that. So operator. So actually, let's do OP is this, and this is OP token. Dot value dot, no, hang on, not value. OP type. So we want to actually create an operator, right? In the OP type, and we'll just basically switch over. Yeah. So this is going to take a token type. So let's do an operator from this. What did I call it? Create operator. Yeah. And this is just going to take a token type. So token type, and we'll switch over. So switch token type. Not bad. We need to give it a name. Yeah. Probably a good idea. All right. So switch type, and then case case TP plus, case TP minus, case TP multiply, and case TP divide, and then the default case. We're just going to yeah, if it's not any of those, then we want to just assert false. Not assert, but we want to print error. Let's see. Error. No, we don't need to put error because this it's already a thing. So we'll just do let's make it operator. Oops. Operator, but found. And then we'll just print the token types. Token types. Type. I think that should work pretty much. So this, we're gonna add Rekka to all these. Okay, so TT plus. So we're going to create the operator. Create it here. So operator equals 0. So we need the type and the precedence, right? So TT plus op.type equals OP plus. And then OP.precedence, if I can spell, hopefully I did, equals prec 1, right? And then it's the same for this, except it is OP minus. OP minus, there we go. Right. And this one is OP multiply, but it is prec 2. And the same thing it did. Okay. So that should create the operator, and then we can just return it. Turn off at the end. And then that should create the operator. We need to put an equal sign here. So that should give us our operator, and then we can figure out what it is based on that, right? So we have that. So we're going to create an expression based on that. I'm just thinking about how we'll do this. So yeah, we'll create an expression out here. So expression. And we 0 on your sides, I think. So maybe we should even allocate it. Since we're going to want to go quickly, so we'll want that anyway. Okay, so actually, if there is not a token, yeah, if there's not a token, then we're going to want to just basically return that, right? Return this one. Right. So this could even, I don't want to do that. So basically, if the next one's not an operator, then we just want to return expert, right? So I want to set expert left-hand side equal to, well, no, we don't even need the left-hand side. We just set expert type equals type 8 and stuff like that, right? So I'm just thinking, how would we do this? So we allocate it, and then it's going to return the painting. Right. Yeah, right now I'm not worrying about free or anything like that. Soon, in the future, I'm going to implement an arena, and then we'll just free it all at the end and stuff. But for now, I'm just letting it leak, right? Okay, so let's see, what do we need to do? We need to check, right? So if let's see, token is operating, the key could be acceptable. OP token. Let's see, if it is not, if it's not, then we're gonna set expr.temp equals expr in, and then expr.value.integer equals equals the current token, right? So a void token. How do we? No, so do we have the token value? So how do we get that? From this tokens data 0.value.integer. Okay, we don't have to do that. I don't quite get that. Hang on. Value.integer equals tokens data 0.value.integer. Okay, so I guess we have the integer value, so that's all good then. Yeah, that makes sense actually. All right, so we can set that. Otherwise, we want to continue on. So we'll just return extra there, and that's the end of that. Except if it is an object. So let's make this function actually. Okay, so bool token in out, and basically we're just gonna switch over it like this. And then just return true or false, right? Okay, so if it is this one, if it's any of these, we can return true, right? Return true. True. No, it can fall through. I forgot about that. Okay, return true like that. Default, we're gonna just return false. Okay, so if it is not, then we'll just parse it as an integer. Otherwise, we'll create the operator, and then we have to look ahead again, right? So, well, actually, so how do I want to do this? So then we can call it recursively on the next one, you know? So we could set expr value dot expr dot right hand side equals parse expression. Perfect. So first of all, we have to consume the first two, you know. So let's do tokens plus 2 actually. That's gonna get rid of the current ones, but that is not gonna work. Yeah, that'll work. Well, hang on. Yeah, so I'm trying to think. When we create the operator, yeah, I think that should work fine. So we should be able to do that. How does token peak work actually? Token peak. Yeah, that should be fine. That should be fine. Yeah, so that will set the right-hand side equal to either just a single integer like this or another expression. And then we'll set the left-hand side. Value.expr.left-hand side equals just the value of the current one, I suppose. So this doesn't take into account order of operations yet. So we'll get there. Equals just this. What is this? That is not right. Actually, this is another one, so I have to do right-hand side. Well, no, that's another expression, but this is, let's get rid of this, like that. Left-hand side dot, so that's an expression, so then, dot value dot integer. So I think I do it like that, if I'm not mistaken. That might be wrong. We'll see, and then we'll return extra. Actually, if we just go like that here, take all of this and put it in there, then yeah, then we can just return once. Let's put that, and we have a lot of issues. So expr is a pointer, first of all. Okay, pointer. Okay, so expr value has no member named expr. Oh shoot, is expr value. Right. So what is it? Expr value. Let's look at that. It's bin. Okay. Value dot expr. Yeah. So value dot bin. Yeah, because it's a binary expression. I forgot about that. Okay. And we need to set expr type actually as well. So expr type equals expr bin. So we need to make sure we set that so we know. Okay, so Let's see. Left hand side, arrow value is the pointer. So it doesn't like that. Alright, so this did not actually work. Setting that up. Destruct expert. So we might have to go back to that even. Let's see if we can get the rest of it working now. Operator type to token type. Hang on, so op.type, where is that at? Yeah, not op.type, but op token.type. Okay. We don't use that, we have to set the operator of the expert. It's actually, yeah, let's just set that like this. So expert operator equals A. There we go. We don't have to think about that yet. Okay, so it doesn't like this still. Use parameter op token. Don't use that at all. Wait, in what? Token is op token. Oh, we didn't switch over it. That's kind of important to have. So this is actually operator. No, not operator. op type. And we'll switch over the type. Okay. I thought something was missing here, but I did not realize that it was that. That's my bad. Okay, save that. Build it again. Implicit definition of token is open, but we have it. So what's the issue? OP type is not a thing. So what is it called? It is. Wait. What is it called? The operator. Operator type. Okay. Okay. Operator type. There we go. Build that now. Token is OP. That is a token. So we're taking the whole token. Yeah, that makes sense actually. So token. I forgot about that. So we have to switch over token.type because this is not the operator type. So yeah, makes sense. All right, getting there. So expected that. So it doesn't like this. Oh yeah, because I forgot to pass the token value, right? So where do we do the print? Right here. Do we have the token in here? We do not have the token, so we'll need the location of the token, and we'll just put the location in here. That's fine. So what we call create operator, we're going to have to pass the tokens data 1.log. Is that right? So yeah, creating from there. So that should fix that. Okay, so we're getting there. Printed expression before token array. Why? Oh yeah, token feed. Hang on. Token feed tokens. Okay, so expert has no. Alright, so it's just called op. It's kind of confusing, but okay. Shoot, no, it's expert value.bin.operator. And so yeah, so now we get. It's just called op. You'll do it. I suppose it is. Okay, so it doesn't like this. Valid use of undefined type, so it does not like this. Let's see. So we do expert, right? And then we put this expert here, and then we actually define expert, which is here. We go like this. No. So let's actually output that to just right. No. It's not okay, that's not what I meant to output there. So how do I thought that would work. I don't know how to scroll in Tmods. Expert and declare. So it doesn't like this. Okay, is that closer? Expert has to be typed out. Right, yeah. But I also define it up here, so you see. Right, because I need to reference it in this one. Unknown type name. Okay, there we go. So let's see if it works. So we call it in here, right? So for this one, so we need to set the arg to that. Arg equals arg. Do we want to do it like that? Would rather just append another node for it. You know what I'm saying? Let's just do that because it's gonna create the expression. Yeah, so that should be fine. Now equals arg, and then dot type equals log expert, not log, but arg expert. Then dot value equals dot value dot expert. I think that should work, right? Not quite. Arg expert design this. So let's look at arg expert, right? What do we have? Arg string and arg int. That's not what I want. I want arg expert. Yes, there we go. Go back. Arg int does not exist then. Native exit. Not equal arg expert, so we need to check that. Alright, and then that wants that. So I might need to assign it differently. Let's see. If this doesn't work, then I will just assign it to a separate variable. Yeah. Okay. So let's do expert. Expert equals plus expert, and we'll set it to that. Expert equals expert. Actually, does not expect a pointer type. So we could change that. So there we go. So that compiles. And then when we go here, we want to just compile expression. So compile expression from node value dot new args dot a dot 0. Okay, yes, just the first argument. We're going to compile it. So let's make that. And then once we get the operator precedence implemented, it will be done in terms of the parser, so we shouldn't have to change this at all. It's going to take an expression, right? Okay, so what do we have to do for that? Basically, we have to recursively search through it and just generate the code based on the left-hand side and the right-hand side. Right. So, so we need to, is the left-hand side ever set to, I don't know. Maybe we should actually print all the nodes first. Let's go back. And we just print node. No. Yeah, we can just iterate it. I don't think we have a function for is less than root.count. And then we will just print. We just want to see the type of it, right? So root.data I dot type. And we could do node types. Like this. Okay, something like that should work. As an arg, yeah, we need to pass it as an expression. Value.expert. Okay, unused parameter, that's okay. let's run. No, not, whoops, I'm gonna volcano. Okay, so segfault. Okay. We don't need to print the tokens anymore. Let's look at GDB and see why. Segfault. Run with in.kano. Right. Yes. So next. And we'll step into here. And let's go through until it actually fills. Whoops. That's not what I thought. No, exit. Yes. Let's try that again. Yeah, I don't think I revoked it actually. So let me do that. Okay, great. Enable. Run kano.kano. Alright, let's try that one more time. I'm going to step into this one. And we'll just go through. Parse native node, yes. It is not yet. What is the tokens data 0.type? TT exit. Okay, so it's the exit one. Yeah, so now we're in here. So I'm going to step into this. Alright, next. So I think this is probably right breaks, right? In here, when we actually parse expression, step. Parse expression. So is this where it fails? Okay, so it failed there. So which one were we calling? Hang on. Token peak. Is that where it failed? Yeah, well, we should probably actually, probably, good thing, let's look at token peak. We need to make sure, well, no, or if tokens not count. We don't really have a count though, so this tokens peak, maybe it won't look like that. So what I'm going to do actually is, let's do something else. Tokens peak. Tokens, and then we'll have the, dot, right? So we will use peak by here. So if you want to look one ahead or whatever, then you can look at that, or you can look at the top one as well. Let's if tokens not count is less than peak by, then we're just gonna print error token count was that, but expected. Yeah, so we token not count was that, but expected peak by. Something like that, right? And then token peak, when we call that token tokens, and we'll pass one for that. And then for this, we're not going to do the +2. We're just going to continue tokens, right? So we need to token consume, and that will get rid of the first one. We need to do it twice. To get rid of the first two. We cannot do that. So how can we do that? And still peek ahead, you know? Yeah, because that creates a lot of issues. Tokens disappointing, first of all. Okay, build that. Doesn't like that. Because we don't put the location in there. I'm gonna put no location for name. So I'm not sure this is even gonna work. Oh, I should do that. I think that is. Okay, not undercode, it's location. Location, there we go. And we have file expression. Okay, let's look at that. Native name. Okay. Yes, we got two natives. That makes sense actually. Wait. So I want to look not at the node type. Let's look at it in GDB because I think you can see it a little bit better. So, right, break main. One with then step into here. Not this one. That's not what I want to step into. Let's go into now it's all a little bit messed up. Let's actually let's go through this and print root.data on.type, which is going to be type native. Yeah, so we want to look at the second one. So print root.data I dot, we have it there. So the node, right? So native. And then the native one, args. Yes, let's look at the native.args. Native.args. What's it called? Value. Yeah. Print root.data I dot value dot native dot args. So print root.data I dot value dot native dot args. Args what? So we have args dot data 0 dot type. Let me actually, let's see, type. Well, it's going to be an arg expression. Okay, that's right. Data I dot value dot native dot args dot data 0 dot value dot expert. Value dot expert. Expert what? Let's look at that. The whole thing. Okay, and we can't. Data I dot value dot native dot args dot data 0 dot value dot expert. Dot value. It is that. So left hand side is this, and right hand side is that. So I don't know if that's right. The operator is right. But then we have the integer is that, which does not look right to me. Let's print the right hand side. That value, that left hand side. I don't remember the name of the left hand side. Wait. Oh, that bin. Okay. And it is that. And side, so it is that. So dot value dot 35. Okay, 35. Is that right? All right, I think that might be right. Let's try it. Let's try to compile it. So we have the compile expression. So we need to first of all, we need to figure out what the type is. Well, so we know it's an expression, right? But we need to get the left hand side and the right hand side and compile it. So switch over expert value dot bin dot left hand side. Well, hang on. Expert type. Do we have that? Type. So the type is expert bin. Yeah, so we want to look at that. Expert type. So this is what we would like. And then is expert bin. Right. And then not right. And then case expert bin, right? So if it's an integer, then we just have to take the integer value and print it just like we did previously here. Okay, push that, and then we want to do that rs.data data 0 value dot expert dot integer. I think that's it, right? And this doesn't return anything. So let's put out of this. Yes, run it over. It's not built because node does not exist. It is, yes, we just have the expert, so we don't need all this stuff. We just need expert.value, expert arrow value. File is unclear, so we need to actually provide the file. That makes sense. Because that is the stream, right? So I'm gonna get file pointer stream. What was file file? Okay, so we can run that, and if we build it, it's not actually gonna compile anything, because first of all, we're doing this. Let's do that. And let's modify kano.kano to just be 34. Build it, and then run it. Kano.kano. And let's look at kano.pattern, and we have push 34. Okay, let's remove make sure it's not from there. Run it again. Push 34. Okay, so that looks like it still works. So that's good. So we have that functionality. But now we do this. It's not going to compile. Let's actually set an insert here to make sure we get to the right place. Assert. False. Unreachable. That's enough for that today. It's just or not. It really should be unreachable, but it's fine. Okay. Yes. So now we need to do that. So we have to look at the left-hand side. And just basically compile an expression based on the left-hand side and the right-hand side, right? Because it's always going to go back to this, right? So if we just call compile expr file expr value bin left-hand side, do the same thing for that. Probably with the right-hand side. Oops, right-hand side. Right. And if we look at Tano, we have at Tano.Parsing, push 35. Okay, that's not good. So just compile the one. So we don't have, oh shoot, we don't have the value of 34. So it didn't work. Oh, so that means there's an issue in the parsing. So let's maybe add just a print statement because I think it'd be pretty easy. To here, right? So let's look at this. So, oh shoot, I know what the issue is because we consume the tokens. Let's create a new one, right? A new token array temporarily, and we'll just allocate on the stack. We'll set the data tokens plus 2. Not count equals tokens count minus 2. Capacity, let's be capacity. Like that, right? And then just pass that one in here. We don't have to consume anything, right? At least not until the end. We might have to at the end. Token pointer from that. This needs to be called tokens data. Plus 2. And this needs to be a pointer, so you just do that. Then if we run it, unreachable. So 46. So I think it's because we don't consume the tokens, right? Yeah, that makes sense. So at the end, we have to consume all the tokens. So where do we want to consume it? We need to consume it. Well, actually, we just do this up here, and this will work fine. Actually. And then we consume. What do you think about that? Because that could work. No, it's not. It didn't even generate 2 though, which is interesting. So I don't think it quite worked. Let's print that. So we want the right-hand side and the left-hand side. Or we'll do left-hand side first. Side and right-hand side. Expert value in left-hand side value here, as well as the value in right-hand side value. Integer, I think. Value. That's not right. It's 5. Oops. I want to run it. Seg fault. Okay. Because the right hand side doesn't have value, so it needs to be that expert side. The right hand side bin. Okay, so bin not that. Is that right? Not quite. Expert has no attribute named bin. Value. Okay, run this. Save fault again. Okay. Shoot, because it is not a bin. So why is it not that? Maybe let me just set this in GB because I don't quite know. Let's T A. We want to break on parse expression. Parse and run with intermarket. Yes. Okay, so next. So let's do this. And print open book. So we have TT plus. Alright, so that is perfect. So we go here. So let's look at so the type is that. Create the operator. Okay, and then we want to print extra value in the left hand side value dot 34. Okay, so we have the 34. We consume the tokens. That's fine. We do that, and that's fine. And then this, let's print extra value. That's an extra value dot bin. Right hand side. Extra value dot bin. Right hand side type is unknown. Oh shoot, because we don't set it yet. Oh my gosh. Okay. Because we set it after this. Okay, there we go. Wait, did it actually work this time? No, so it doesn't generate it all. Okay, so you don't actually traverse the tree properly. Oh, we do have the left-hand side and right-hand side. That is correct. So I will leave this coming now, just for now. So when we're compiling it, we compile the left-hand side and the right-hand side. So we're int. Are we not setting the type properly? Well, what's the deal with that? Maybe we should look at that. Let's do db.kano and break expression. Hang on. Okay. Oh, not that. Dot slash break compile expression. And run kano. Yes. So let's look at that. So that is that. So let's step into this. And let's print expert type is unknown. Shoot, so we must not set it. So we just skip to the end. Let's do assert. Let's add an assert here. Assert false on reach, because we should not get to this point. So that's gonna actually fail. That's gonna rebuild this and run it. Then we can actually kind of figure out why it does that. So we don't set the expression type. We're not setting it properly, at least when we are parsing it. So type is that and type is this. So why is it not? Curious. Left hand side is that. We set the right hand side to this, and the right hand side ends up just being an integer, and the left hand side also being an integer. Oh shoot, because we don't set the type of the left hand side. That's what the issue is. The value dot in the left hand side type equals 30. Okay, and let's look at push 35 and push 35. Yeah, but we need to do the add as well. I forgot about the add. It pushes 35 twice, which is not quite right. Why would it do that? Right. So we go to the left hand side, and then it triggers this. So we push that. Then we exit out of this, and we go to the right hand side. And it should do this. Let me look at that, and then I will do the actual add. Let's push the add down. Actually, here is where we will push the type. Let's just based on the type. Well, let's just do add, and it should work, right? Look at that. We don't need this. Now if we run it with that, and we look at Parsing. Yeah, so we had that. So yeah, so now let's step through DVD. Let's break on compile expression. TV enable. Run internet. Yes. Alright, so let's go here. So so we'll step into this. We'll print expert type. So it is expert int, right? And we'll print expert in expert value. print expert value left hand side. Whoops. Print expert value dot bin dot left hand side. Left hand side arrow type. No, it cannot access the memory. Why? Hang on, what's the why? Oh shoot, because I need to do the no, I didn't. Why doesn't it like that? Huh. It's your 35, so we have a 35 there. These are some concerning things here, so I don't know what that's about. Let's step into it. I don't want to step into that though. Print expert. Oh yeah, so we don't have a left-hand side now at this point. That's what all that was about. So that's 35. We go to next. Then we're here. So let's step into that. Expert type, right? Expert value dot integer. 35. So why is it 35? Because it wasn't before, right? When we were looking at the left-hand side, right-hand side. Oh shoot, because do we not consume all the tokens actually? So we need to consume. Yeah. Yeah, I think we do want to do that, right? That might not be. That doesn't work. So let's go there and see how many times this is actually called. It's multi-called community comments. Okay. Parsing. Maybe not. Why did that cause a seg fault? Yeah, why did funny stuff here cause a seg fault? What? That's the right number though. I should look at that seg fault, but that is concerning. Break thing. So let's just see which one it's in. It's in the parse. No, it's not in the parse. So it's in the generate. Yeah. Okay. And next. Step into there. And where is it in here? Okay, it was on the first one. Next. Step. So something is getting messed up in the file name. Ooh, why does that happen? File name. So we pass that. Does this get cleared or something? What? Okay, let's actually we should step into that function file. Step there. Next. The malloc failed. Okay. Are we out of memory? I should probably add the assert to the malloc. So let's actually use malloc like that. You know? I want to place all of them, but then that's not effective. Let's use a function. And I'll just make an inline function thing. So this will be how do you do it? Inline void, right? Because I don't have inline as the keyword. And this is going to take a size, right? And then the function equals size of size. Now I'm just gonna assert. Assert pointer is null. By more than not size of size, but just size. And then return pointer. Okay, something like that should work, right? Whatever it is. So custom now. Yeah, I'm gonna call it custom now. That's all. Mm-hmm. I need my functions. Okay. Okay. No, not really. How you do that? Whatever. I'll do that later. Save faults. We still save faults. We probably allocate more somewhere else. Right. Let's do GDB again. Break on. What is it? A pane extension. Whoops. I pane pencil extension. That's what it's called. One pane. Okay, let's print file name size, which we don't have yet. Let's print file. Print file name size 9. Okay, that still failed. But it's seg faulted. So it's actually calling the method. It's seg faults. So we have a big issue somewhere. Go through all the mallocs, right? Just replace them all. Okay, so that's all of them, I guess. Again, I'm gonna replace it with an arena soon, but I'm not doing that yet. I'll do that. Still seg faults. But if I don't print up here, then it does not. That is very concerning. Let's run through GDB, right? Let's break on compile expression. Or no, let's break on parse expression. There we go. Okay. So custom malloc, we do that. Token, we do that. We set all of them. So we can print the values here. We go through there again. Let's print extra value. Per value. Bin dot left hand side. Print extra value. Bin dot left hand side. Cannot access that. Left hand side. Not value, but value dot bin dot left hand side. Huh. Value dot bin. Dot left hand side. Print that. Why is it on no? Oh, because we said it here. Okay. Side value. Right hand side value. Okay, so both 35, but they are not. Oh. Oh shoot! Wait. That was not right. Oh shoot! We're not supposed to set it right here. That's what the issue is. We said it twice. Yeah, that is a bit of an issue. It's still saying false though. Why does it do that from adding a fence in? There's something seriously wrong with it. The BKF is working. Yes, that's right then. So, let's try review plus 100 also. No, so that breaks. I expected that today though. Alright, so what if we just did it here? Is that one? Yeah. Okay, so we have that. 4 plus 500. Okay, there's 4,500. So those work. Why can we not add to 50? So let's walk through the DVD, right? Enable. Let's break actually on parsing. Let's see. Is it? It might be in the parsing spec. Let's just break main and then we'll step through and see where it's at. And run with. It's in the parts, yes. So let's run. Yes. And we'll step into that. So break parts expression and continue. Okay, so now we're in the parts expression. So we can walk through this and see what it is. Expert bin, it operator. Side is that. Yeah, because we set the left hand side always 2 inches. So that's probably what it is. So we consume the tokens. We set that way, which we don't need anymore. So it's that, but the left hand side doesn't. We do still have it. Right. So we have the left hand side. But we're going to set it twice. So we can't always just set it to an integer. So let me think about how it would look, right? So if we have, right, say 100 plus 100 plus 100, right? So this is what we think about. So we'd have a single one, which would be this plus. So have the left hand side is that, and the right hand side is another one, which has the left hand side as an integer and the right hand side as an integer. Right, so wait, that might be fine. Whoops, thanks. Value 500. Okay. What were we trying to do again? 500. So that is left hand side. That's actually right. Consume tokens. And then why are we? Oh yes, we're parsing it again, but it's just going to be this. So let's do that. Print expert. So we just got again. So we go next again. Print expert value dot bin left hand side value. Integer is 500. Okay, and let's do the right hand side. Right hand side value. Integer is 50. Okay, so that looks right. So then print expert value dot bin dot right hand side value. Whoops. Dot bin dot right hand side value. Okay, so I think it's that one's a bin, right? Value dot bin dot right hand side value dot bin. We need to look at both of them. Dot bin dot left hand side. Maybe we can actually look at the value of it. Okay. In that left hand side value. 500, okay. Side value dot bin dot right hand side value, which is 50. Okay. So that looks right to me. So where does it actually say fault then? Did not say fault. Wait, what? So where does it say fault? Oh shoot, when we're doing DA append. Okay, so we must have an issue in our DA append. So it was not this one though. Yeah, let's use my malloc in there instead of this, right? We'll use realloc though. But custom malloc could be, well, we could even make it, doesn't matter. Custom realloc, right? So we'll just pass null, you know. So then we could do equals realloc, their size. Yeah. Pointer, and then we can go through everywhere that we do custom. We need to spell it right though. Custom malloc, we need to change it to custom realloc. Oh, and we need to pass the null as well. Custom malloc, it's null. And then custom malloc. I think this is the last one. Yes, okay. So we can say that. And then we want to use it up here as well. Custom. Whatever that, that's brilliant. Okay, let's get rid of that new token state, because that's kind of annoying. Still seg faults, huh? Seg faults regardless. Let's see if it actually seg faults in the same place. Break on not parse expression, but what is it? What's the parse native node? Yeah. Run a method. Yes. Okay, we'll step through. And does it fail in the same place when we try to append? No, it does not. But that's the first one, right? Yeah. The next one will. So somewhere in between those two caused a big problem. Okay, could I use Battleground for this? Like, would that be helpful? I don't know exactly how to use Battleground. All word for, oh yeah. Okay, weeks. Just output that out. Maybe not. Okay. Heap summary, we lost stuff. Domain core, access not within mapped region. Increase the size of the stack. That's not what the issue is. Alright, yeah, how do I do that? Okay. That's your file. Did not work. What? Let's do it first. There's long time. Okay, there we go. Yeah, so then we can actually read through it. So, uninitialized size value of 8. Uninitialized value of size 8. Let's see. Yeah, we don't allocate the left-hand side, do we? That's what the issue is. Okay. Shoot. So do I want to allocate them? In here, we need to allocate the left-hand side. Expert value. The left-hand side equals. Oh, size of. Why do that? It does not cycle. Okay, so we can just make sure that that is all of the issue, right? Actually, let's look at the outline because we have to run it. So, conditional dump formula depends on uninitialized values. So POP token, that is not. But the right-hand side gets allocated in here, like regardless. So that should be fine. Yeah, why that's uninitialized though. Alright, well I can go through that, but it doesn't cause a seg fault right now, so it's fine. And then obviously you have these and stuff, like I already went over that, so you're good. Okay, so that is good. Let's look at kano.parsing. Okay, and it actually worked. So kano.kano, what if we do plus 500 again, you know? Try to run. Yes, and we have, okay, actually this isn't gonna work. Yeah, we cannot do the add after all of those. Well, no, we can. Actually, I guess it doesn't really matter. But I would rather have it be like that. It might be, once we get to the order of operations, it might be, which, probably gonna have to do that tomorrow, because we are getting close to the end here. Have been streaming for an hour and a half. But yes, so let me just fix that. That should not be too hard, though. Alright, expression. So, at the end of this, well, if it's a binary type, I want to do it like that. Let's try that. Yeah, so that's not right. Alright, well, let me see what happens if I try to assemble this thing. I actually can't look at the output. I don't. Oh yeah, because we exited. So 60. 60. Why would it be 60? Push 500. Add. So that will add the top two. So 550. So 550 plus 500. So that'd be 1050 plus 34. So why would it say with 60? Wow. If I push 5 here. Now we compile. 5. Wait, what? What? 60. What the heck? Can I look at the bytecode? Text dump. The hex edit. Let's hex edit. Okay, so I don't really know where it would be. It's gonna be kind of hard to search for. Yeah, okay, that might not work. If I print it, you know, because I can actually do the debug print. Print the top row. That might be a stack overflow actually, but that's okay. As int is that. So it is 1084. Is that exact? I think so. Yeah, so that's actually right. But for some reason it exits with 60. Can we not exit with value greater than... Oh, shoot, we can't. I forgot about that. Oh, shoot, you can't exit with too great a value. It, like, overflows. So that's actually what the issue is. Okay, I thought there was a serious issue. But if we just do, 1 plus 2 plus 3 plus 4, you know, so 4, 5, 6, 7, 10, right? 10. Okay, like that. Okay, there we go. Okay, that is perfect. That is perfect. So, yes, let's actually support more. Well, no, we still need to fix the one issue where the add is not in the correct place. So, how do we want to do that actually? So, let me think about when we're actually traversing this. What it'll look like. So, we'll come in here. It's gonna be a binary type. Yeah, binary expression. Yeah. Try the left-hand side, which is gonna be an integer. And then we do the right hand side. But after that, so I don't know how we would do that exactly. We do need to switch over the type though. So let's switch over expert value dot bin dot operator, and then case op plots. Do this. Back up. I always do that. Okay, and we put this in. Case op goes like that. Minus. Okay, and then I'll copy the rest of these. OP big and more. Okay, so this one we'll put sub, and we'll see how badly it's broken when we do that. is more. I think it's just more. This one's div, right? Okay. And why you name operator? Okay, that's what it was. So, okay, now let's do sit with 5 minus 3. And let's look at asm. Push 5, push 3, and sub. So I think that'll work. If that is the right order. Ooh, I hope that's the right order. If it's not, I'm just gonna change the code because that should be the right order. Build slash tasm. Tasm. Build slash type. Go that. 2. Perfect. Paul Pass followed. Thank you. I appreciate that. Okay, so 2 is right. 2 is right. So then let's do 5 times 3. So we have to go through the whole step. All the steps. Tasm and fire. Echo that. 15. Okay. So that was good. It looks like that works. But what if we stack them? Plus 5. So there's no multiplication precedence. So if I put like multiplied by 2 here, it's not gonna take that into account just yet. We'll get there. Let's see if this works. So that'd be 5 times 3. So it should be able to do that. That'd be 15 plus 5. So that should be 20. This is not that slash mean. No, that 40. That's not right. Let's look at any map pads. So, ooh, we put the add first. That's not good. Why would we put the add first? That's interesting. Also for this, I'm just gonna put it here for now, but we could have power star 50 times, right? OP types like that equals, we can add, sub, multiply, and divide. And we could just do this, you know? Print and then put some S there, and we could do OP types for value dot in dot OP dot type. You know what I'm saying? That'd be pretty good. Okay, save that. And then it should work exactly the same as it does now, which is not working, but no, dot has them. Yeah, so it's the same thing. So why is it this order? I don't know. Oh shoot. So we finished that first. So we want to that's a bit difficult. How do we do that? We want to do the left hand side and the right hand side. After we do the first one on the right hand side, I'm thinking here. So that's a I don't know. That is kind of tough. This becomes 40 because what we do is we add 5, so that's 8. Yeah, 8 times 5 is 40. Okay. How can we do this? So what if we, I'm just thinking, I'm not sure this will work, but basically add a blank here. So is operator, and we call that. So when we do this, we pass false. We do this, we pass true. So then, just regardless at the end, if is operator, then just look at the operator. File. How do we do this? %s slash n types expert value dot bin. Oh shoot, we can't do that there either. So how? Yes, that is not good because we do not have access to that operator. We only have access to it on the higher level of this one. So we might have to do that a different way. We might have to compile it all differently. That's not good. That's not right. Bin. think that's the right one. There's a lot of white space here. Okay, get rid of that. Okay, so let's make sure it still compiles. It's not. Because I forgot a closing here. Okay, so what else could we do? I would really like to get this working. Let me think. So the left-hand side, it's going to be an integer. The right-hand side could be an expression. But if it actually, you might be able to still do that. Let's see. So foo is operator. It is operator, then do this. In this one, you know? So first time, let's see. So for this one, we're gonna, it doesn't even matter what we pass. For this one, we want to pass true. And we'll pass true for the first. No, we want to pass false for the first one. Let me actually call it. So how do we want to do that? Let's look at the behavior of this creates. So, okay, yeah, then we get the and in the wrong place. We don't get the multiply at all, so that's not good. Then we still need the one at the end, that's why. It's still need the wrong place though, so. Kano dot hasn't. Yeah, so this first one does not work. We need it to get too many at it though. So we still get at the end there. No, okay, so this it's probably isn't gonna work out. So I'm gonna do some here. I'm trying to think, like, how else are you supposed to compile? Yeah, I'm probably doing something wrong. So we have the left-hand side, and we call it recursively, right? And the right-hand side, we do the same thing. Dang, So like for this, we want to print the higher level value of it, of the operator. Like in the other order. So how can you do that? Maybe I could read about it. So expressions. Can we look at that? Right, so not that. So if not compile, trunk, yeah, okay. This is the interpreter's book. So I'm gonna look at and yeah, not that single pass. I want to look at actually compiling, right? Compiler design. Not regular expressions. Code generation. Can we look at something here? Does this have that? Zero or one? Expressions, compiling expressions. Let's see. Yeah, so this is what it looks like, right? Well, not exactly. Yeah, but once we handle the precedence, it will look more like this. So how would they handle this, right? So you want, which one do you do first? do the multiplication first, though, right? Oh, shoot. So this is for this. So 5 plus 9, we go first. So we start at the bottom, right? 5 plus 9. Yeah, okay. Okay. So our tree must be generated improperly then. Right. Okay. Yeah, let's see. If I'd be able to print an expression, right? Void expr. Let's take an expression there. Printf, just do if expr equals expr int, and just print it out, right? Print the expr value target. Otherwise, we just call it expr value print that left hand side as well as the right hand side. I guess I need to get rid of these because they don't go there. I just want to try to print the expression, you know? Print the expression here. It's expression. Then return. So just look at the first one. To compile expression. Yes, we don't need a false there. So we can get rid of that. Return with the value. Yes, this is a void function. We don't return with value. Okay, let's run. Okay, so we have 5. Then we have 3 and we have 5. That's like the B order, right? 5, 3, 5. Let me make sure. So let's make it 6, right? So it should be 6, 3, 5. Okay. So the tree looks like the let's see, I can probably draw it to visualize it, yes. So we could look like this. So we have one here, which is 6. Hey, I make it small. 6, there we go. And we have another one over here, which is, let's see, so let's make this, which has the plus. So they're all plus, right? Yeah, well, no, this one is actually multiply. Let's multiply, right? That's the left. Then the right is a plus with the left-hand side of 3 and the right-hand side of 5. And if we look at the generated assembly, we did not actually properly generate. So let's go back and make sure we do properly generate it, because then we know what that looks like. So we can take it and generate it. We can look at this. So we push it in the proper order, right? So we want to push. But that's actually, yeah, so that is how the tree looks, you know? But that's not right. Because we do 5 plus 3 first. 5 plus 3 first. And then we do that. Yeah. So if we actually change it. So if we do times that, right? It's going to be right. So that's going to be 5 times 3, so that's 15 plus 6, so 21, right? And let me not even look at it, but build slash Parsing. And higher can not 10. Okay. 21, yes, okay. That's what it is. So yeah, because we don't take that into account yet, and we built the tree recursively, that's what's going to happen. So we will need to look at the actual precedence using using this, which that's probably going to be for tomorrow. So it does actually work. It does work. It's just not how you would expect it to work, you know, because we don't take into account different precedents. So we'd have to basically do this, right? So if we look at how we are pressing it right now, let's see. So parse expression. So I think we're actually fine. We are fine with what we have. We have an expression, right? And we don't have to worry about that. So left-hand side. So we pass in the left-hand side. Parse primary. So what is primary return? So I'll need to look into this, how this works exactly. But then the precedence. So the starting precedence is 0. We look ahead, right? So let's say we start, let's say I'm going to assume that we're going to start on an integer, right? So the left-hand side would be the integer. Then we look ahead. So that's like what we're doing here. Token peak, right? And then like we look at the precedence of it, and then we can look ahead again. Oh, no, we don't look ahead again. We set it equal to the look ahead one. And then we go to the next token, So we have to consume one. Okay. And then parse primary. How do we, like, so what is parse primary? I'll need to look into that. And then we pick the next token, so that's going to be the next operator. And then right-hand side is recursively call this. That's sort of like what we're doing here, right? Let's see, if the precedence is greater though, then we call that. So that's sort of how it will look in the tree. So if we look at the tree, right? So this is the multiply and this is plus. We're gonna generate it like that. So say we have 5 plus 3 times 2 plus 7, right? So what you need to do is we're gonna build it like this. So the bottommost ones are gonna be the 3 times 2, because that's what we want to do first. 3 and 2. So it's going to look like that, multiply. So these are going to be the first ones that we do. And then we can build the 5 plus 3, right? 5, 3, plus. So I'm just trying to think about how it's going to look. So I have that. And then how does it attach it? Because it doesn't actually attach like that. Because we do the 3 times 2 in here. So we actually want to attach this one. I did that wrong, right? So this is going to be plus. This one goes here, but then this one is connected over here. So I drew it too far away, but that's okay. So this is times, right? And then we have the plus 7. So this actually goes on the bottom. So where does the plus 7 go? Plus 7 of this one. So, okay, so this becomes, how do I erase like this, right? Let's see, that doesn't work very well. Basically, this is plus, right? Plus. Over here is 7. And the left-hand side is times 3 and 2. So this is what we're going to build. 3 and 2. So, I got a little messy. Basically, plus 5. So we traverse down here. And then we're going to traverse down here. So we do 3 times 2. And we do that first, right? So that becomes 5. And then up here, we're going to do 5 times 7. So that's actually a 7 there. Yeah, so 5 times 7, that's 35. And then we do 5 plus 5. So then 40. So that should be right. 3 times 2. 6. Wait, 3 times 2. This is times. So I messed actually the whole thing up. Okay, that's going to be 5. And then, wait, no, that was right. Oh, okay. This isn't times, so that's not right. Yeah, so then it's 12 plus 5. So it's going to be 17. Yeah. So that's what it's going to evaluate to. So basically, we need to look at the precedence here. So the precedence of this one, actually of just this single operator here, is 1. Precedence of this one is 2. Precedence of this one is 1. So we look at this, and we see that the next one is a higher precedence. So we need to do the recursive thing on it, right? And that's going to build the tree down here. Well, we call it recursive, like how we are currently. And then we set the left-hand side equal to this one, and the right-hand side equal to that, right? And then for this one that we actually build here, we'll go to this one, and we'll see that it goes down. So we're going to build it more iteratively, where we go like this, you know? So we set the right-hand side equal to that. So basically, yeah, we switch between left and right. I'm not explaining it very well, and I don't fully understand. So yeah, the next stream, I'm going to implement it and hopefully understand it better. So yeah, I'm going to do a lot of research on it, but I think I'm getting how it's going to work. It's starting to make sense. So yeah, I will commit this, and then that's going to be at the end of the stream. And yeah, the next one, oh my gosh. I think I just added, no, I just added all this. I thought I did git add slash and added like the root, but it did not. So, okay, yeah, so implement the start of section parsing. Now just need to take into account precedence. Now this isn't going to include shoot. Slash VG4. Okay. Git that's it. Move 4. Okay. And push that. Okay. Okay. There we go. So done with that. Let's remove all the. I guess I did just remove it. Okay, perfect. So yeah, that's gonna be it. So we're not gonna take into account parentheses yet. So we'll get to that because that sort of changes. That's just gonna be a higher precedence. like precedence 3 or whatever, but we're not there yet. So let's get this working, and then we'll get to that. Okay, so yeah, that's going to be about it. Thank you for watching, and I'll see you guys next time. Bye.